Welcome, welcome. If you want to go, it's up to you. You can go. I don't want to force you to stay. It's going to be an awesome session, I promise. But if you need to go, it's fine. You can catch up the recordings afterwards. Anyway, good afternoon, everybody. My name is Jelle Druyts. I'm a Belgian engineer working for the Fast Track team in Azure. That is actually a pretty new team, so I won't hold it against you if you haven't heard of us yet. Our mission is we're a specialty team that works inside of Azure engineering to onboard customers onto Azure. So that's what we do. We make sure that they're successful, that they start off on the right foot. So we're pretty all around in Azure. And one of the things that I do for customers is work on identity stories. There's plenty of things to say about identity. In my case, I focus mostly on the developer part. So it is about Azure Active Directory. The nice thing is, before my role into Azure, I was also supporting customers on-premise. So there's a market as well for people that are on Active Directory for federation services, for example. So all of the things that I'll cover here today, especially regarding the flows and the authentication scenarios, they also work on Active Directory federation services on premises. But here, for the purpose of this session, we'll just cover Azure Active Directory. It is called a deep dive, so we won't be spending too much time on slides and high-level blah blah of what the whole setup is and what you can do with Azure Active Directory. I do want to take a few moments to focus on why you should care and why I think it's a big deal, because that sort of sets the stage for where I think lots of customers can get a lot of value out of this service without having to pay anything for it. Or if you want to go beyond what the free capabilities are, then at least you can start thinking about additional scenarios. But the base level capabilities are all free, so that's nice. So just really quickly, if you're not familiar with Azure Active Directory, I would be sort of surprised in the sense that lots and lots of millions of customers are on it already. So if anytime you sign in to the Azure portal or to any Office 365 property like SharePoint Online or Exchange, stuff like that in the cloud, then you always go through Azure Active Directory. So it is a service that is scaled at planet size, so it is covering billions of authentications every month. So that means that there's a very big team behind it that is making sure that everything is operational, up and running. It is doing a lot of security monitoring, a lot of attack vector checks, making sure that the service is healthy and that you can rely on it for your core mission critical identity scenarios. So if this thing is down, basically that means that Microsoft is practically down as well. It is really that important to us. What does it do? It is a directory and identity management system, so you can put your users in there and you can do authentication scenarios against the directory. You can store users in groups and stuff like that. We'll cover briefly in a few moments. But the nice thing for modern authentication scenarios is that it's not an Active Directory that you know from on-premise with Kerberos tickets and the low-level on-premise kind of details and the protocols that used to work for local networks that did not scale, that does not work at planet scale or at cloud scale. So that is why Azure Active Directory itself is based on modern protocols. It's using REST, HTTP all the way, so you can use this with any device from an IoT device low-powered to high-end servers, batch services, all needing some identity capability. So that's really the big reason why this open approach to HTTP REST-based is important, because it allows any device, any user in any kind of broadband, low band, just countries where there's no broadband penetration, whatever, they can all use this service to get identity and sign in and access and authorization scenarios working. So the bottom line is, if you are developing for Azure Active Directory, which is hopefully why you're here, that means that you do not have to worry about the users, in the sense that you don't have to worry about storing users, managing users, making sure that if a user leaves an organization, that the user object in your database is cleaned up or whatever. And most importantly as well, if you look at it from a developer's perspective, and I'll just jump to my feature number 1 there at the bottom, you never have to store a password again. And I guess if you take a look at the samplings from the news, it's all over the place where there's breaches every single week on small scales, but large scales, like the Yahoo breach that was a few years ago. Apparently every single Yahoo account got compromised, Equifax, just loads of things. And most of it is down to having a system in place where identity is not your core focus, You're trying to read up on best practices. You're storing perhaps a hashed version of the password, which is please the very first step. But even then, there are attack matrices against that. So it's not that you're hashing it because you read it somewhere, it's a good idea, that it's secure and that you're never going to be breached, right? So there's lots and lots of details around identity and storage of accounts and passwords and credentials that are really complicated. And that's why Azure Active Directory is such a nice thing, because it abstracts away all of that complexity and gives you one endpoint or one flow that you can use in your applications itself, and you don't have to worry about any of the authentication scenarios, none of the security critical things like multi-factor authentication, having global scale. All of that is just managed by Azure Active Directory. And depending on your platform of choice, it's a couple of lines of code, and I'll show that in the demo later on. It is literally a couple of lines of code that you add, and all of that goes away. So I love that. And you could say, well, instead of writing it yourself and doing that database thing yourself where you're storing the users and the hashes of the passwords, etc., you can also lean on top of existing frameworks. So for example, ASP.NET MVC has an identity subsystem, so you can use that as well. The only downside is you're still hosting those users in your own database. The guys at the identity team have taken security into very serious consideration, of course, but it's because the next slide you'll see there's things that you cannot do at that local scale that you can do in a global scale that Azure Active Directory builds upon. But I'll jump into that briefly. So what does it give you as a developer? It gives you the opportunity to outsource the identity pieces. It can be used to manage users, put them into groups, but not only users and groups that are then synchronized from your on-premise Active Directory if you have it, so that can be handled. But you can also go farther and implement roles. So you can implement role-based access control inside of your applications based on the identity information stored in Azure Active Directory. You can query for those group memberships. You can check for relationships between entities. So there's a graph API, which is kind of the canonical way that Azure Active Directory thinks about users, groups, and applications. So that is all programmatically accessible as well. And then bottom line, the middle part is probably the most interesting or important part is I want to just get my users to sign into my application. So you're building a website, you're building a mobile application, maybe you have a batch service that needs to call some other access service. Loads of scenarios where you want to have some way of representing the end user who's holding a device or using a browser or is on a tablet, and have that identity trickle through all of the layers of your architecture. So it could be as simple as just signing a user into a website, but then typically, once the user is on the website, they'll still have to go through a couple of other calls. So they might be calling another backend service, and that backend service also needs to know who the original user is. So they need to do some role-based access control on behalf of the first user. Instead of just relying on that middle subsystem there saying, well, it's a user, it's fine, you know, I'll give you the username. Well, if the middle tier is breached, then how are you really sure that the backend call can trust that system? So you want to have that identity of the end user travel all the way through the layers of your application while still making sure that this information cannot be modified and can be trusted. So that's where security tokens, signatures, and certificates and those kinds of things come into play. So that's all based on standard protocols. So we have OpenID Connect, we have OAuth 2. There's also support in Azure Active Directory for WS Federation and SAML and stuff like that. Those are implementation details at this point in time. I'll show you a couple of the flows for sure. But the end result is that the application itself, by the end of the whole authentication dance that the user does with Azure Active Directory, but the application doesn't care about, at the end of all that flow, you simply get a token that represents the user or represents what the user is allowed to do. Could even be that you don't get his username or email address, just a claim that says, this user is over 18 and is legally allowed to gamble on this site or whatever. Right? So it's giving you the application or the resource being accessed just enough information that he can make a trustworthy decision on the authentication and or authorization aspects of that end user. And then the token can be used to create new tokens to further call downstream services so that identity can propagate all the way up to the back end where needed. So coming back to that idea of the security-related features, and this is something that you cannot really do with a local scale application or a local database or even an Active Directory Federation services that is only hosted on-premise. Some of this you can do, but in Azure Active Directory, the big thing is that there's billions of authentications, so they can do scanning, security attacks, machine learning on top of all the authentications taking place, and making sure that your account data, which is probably very critical to your company, is going to be secure. Some of the examples that they use is unlikely travel. So if you may even experience that if you are developing an application and you're working on a local workstation, you're logging on to the Azure portal, for example, and then you jump into a virtual machine that is hosted in the US, and you sign into the same portal, you may get a prompt that says, hey, this is kind of funny. You're signing in from Amsterdam at 2 p.m., and then 13 minutes later, you're signing in from the US. That's unlikely that you've been able to travel all the way from Amsterdam to Redmond in 30 minutes. So those kind of things, either they're going to get in your face, depending on policy, or it's just going to be an audit, and there are going to be flags spinning up, and security managers can get alerted from those kind of things. Other features that are pretty hard to do is cross-tenant scanning, so they can see that multiple attacks are happening across multiple tenants on the same kind of user account. So a hacker is trying to log on with a John Doe at Contoso, John Doe at Fabricam. That is something that is not specific to your organization, but at the back end, because it's a multi-tenant system and all of the different tenants wind up in the same infrastructure, that is at that level that they can also start alerting and monitoring for security breaches. So lots of things, also working with the security teams where they know for botnets, if they roll up a botnet, for example, they know all of the infected machines in the botnet, and then they can correlate that back to attempts to sign in from those infected machines. So anyway, so lots of stuff going on, and I like that because that's work that I don't have to do as a developer. And you could say, well, it's just an application, but if you're moving to the cloud and you're exposing your data and your users, these are the things that would take years to build, and now you're basically getting them for free, or at, depending on what kind of Active Directory, Azure Active Directory SKU you want to take, these could be premium features where the company wants to pay, but those options are available to you. Something else that's coming up a lot is privileged identity management. Not too often, well, it's relatively young, but that's a feature in Azure Active Directory where you can say, by default, it's sort of a UAC in Windows for admins. So this just-in-time activation of, hey, by default, you're a normal user, but sometimes we realize you're going to have to use an admin account to do something in Azure. We just don't want to have you running around with an admin account all day long. So in the privileged identity management suite, you can say, I want to have just-in-time access to this admin account, or I need to get elevated to an admin, and I need to have that for, let's say, 2 days, and then after that it's automatically shut down, but at the same time it's being audited, who's getting that and why and what they're doing during that time frame. So it's just making sure that all of those auditing policies are in place. Anyway, so those are security features that you don't have to build, so that's why I'm just mentioning it. It's nice that you just get that for free. So then, if we switch back to why is that interesting? Well, if you're going to develop an application for Azure Active Directory, there's not that much you need to do. In essence, you can read a lot of books and you can read a lot of articles. And the nice thing, well, nice with a grain of salt, I guess. The nice thing of the, and now I speak for the Azure engineering team, so I changed into the organization, so I need to be a bit careful of what I say, but they are very much focused on delivering samples and blog posts on individual features and very fine-grained, here's a sample on doing OpenID Connect sign-in, that's it. Or here's a sample on if you want to do a daemon sign-in using a certificate. But if you take a look at your applications, you probably have a bunch of different applications. You have some backend services, you have a front-end API, you have a web application, you have a mobile application. There's all sorts of things going on, and just that one sample doesn't really cover it. So that's why I'll be going through an end-to-end scenario with multiple different types of applications, calling additional backends and stuff like that. So that is why I think it's interesting to take that more broad perspective of what kind of applications you can use. If you want to get into loads more details, Vittorio Bertocci is a well-known identity program manager in the Azure Active Directory team. He wrote an extensive book on how everything works behind the scenes. It's interesting, and you can read up a lot, but it's not critical to get up and running in a secure and simple way. So what I'll show you today, hopefully, are a few simple steps. And at the end, if you follow these 3 steps, you have an end-to-end working scenario with all your security offloaded onto Azure Active Directory. And to be honest, it's really not that big of a deal. I will be using mostly Microsoft's technologies, so I'll be showing ASP.NET MVC, ASP.NET Core, a user signing from a Windows 10 application, or a UWP application, stuff like that. But this is equally applicable to all of the other platforms. You can call these endpoints from Mac, from Linux, from any platform. We have support for client libraries that call into these protocols as well on most of those platforms. So there's no worry here. I'm just trying to focus on something that I can run within a single instance of Visual Studio to make it easy for you to follow the flow. So just as a quick summary of what happens behind the scenes, but again, it's not something you need to know, because at the end of the day, we'll just get a token, as I mentioned. But just to show a bit of how a typical sign-in would work, including once you've signed in, let's make a backend call on behalf of you as the end user. So what happens typically, the user browses to your web application for the first time. So you can imagine that the browser is going to the Azure portal or is going to your own application. It doesn't matter, but the application needs to have an idea of who you are as a user, right? So you need to have identity information. So first thing is the browser navigates to your application. The application doesn't have a session. You don't have a session cookie or any other means of understanding what that user was before. So the application says basically, I don't know who you are, and instead of the old way is, here's a form, and enter your username and password, and if you forgot your password, oh, now I have to implement forgot password flow, do a text message or SMS or email verification, all of that kind of stuff. Never mind. All you need to do is say, well, I don't have a session with you, dear user, but please go ahead and sign in on my Azure Active Directory account. So this is where the redirect happens into Azure Active Directory. So the web application itself, you as the implementer of the application, only have to do a redirect. And middleware and frameworks are there to help you do that, so it's super easy. So it redirects, basically saying, make sure that you sign in. And here, typically for modern web applications, you'll go through an OpenID Connect flow, and that is just a layer on top of OAuth to ensure that you as a user are signed in, but the application gets some identity information about you as well. So it launches an OpenID request, and this is a very short summary as a simple arrow going back, but in here all sorts of things can happen optionally. For example, you may be prompted for a multi-factor authentication sign-in. You get an SMS that you have to reply to. You could get screened in the backend for all sorts of unlikely travel or whatever other things that need to go on. And this is driven by policy. So if your company decides one day to the next to enforce multi-factor, it's not up to you. You as a developer don't have to go and build in additional screens or call additional APIs. It's just a policy that you enable on the directory, and they'll happily get your users through a multi-factor setup. Something that I forgot to mention before is you can also do conditional access. So for example, if the user is coming from an untrusted global public Wi-Fi, then go through MFA. If they're on the corporate, Wi-Fi or on the corporate LAN, then never mind, they're trusted, it's fine. So those kind of checks all happen at that little point in time there. It can be an extensive flow, can be a really simple, hey, we notice that you're on the local network, we have Kerberos set up, it's fine. We do pass-through authentication, which is a new feature, and just forward you directly back. Also interesting to note is that if you're using a non-browser device, so typically on your phone or tablet, this may happen in a browser pop-up. Because otherwise, if your phone or whatever application that you are building would have to build all that in, then you can't do it driven by policy. So you couldn't be able to just magically enable multi-factor authentication from one day to the next, because it would mean that you would have to adapt all of your applications. In here, that's why they pop up the browser screen on the phone or on the tablet, and then you go through that flow driven by the backend, driven by policy, and the application never cares. So that's why you will typically see a browser pop up on any platform, even if it's not a native browser web application. So what happens then in OpenID Connect, you get two things. You get, or depending, three things. You get a token, which is an ID token in OpenID Connect. That is a thing that is specifically meant for the web application to know who you are as a user. That is a concept that does not exist in OAuth, but multiple people have in the past abused OAuth to glean information about the user. Don't do that. Just use OpenID Connect. Take a look at the ID token coming in, and that contains key value pairs, claims. For example, what's your username, email address, UPN, whatever claims you want to emit from Azure Active Directory. So that's the ID token coming in, and then you also get an authorization code. The authorization code is a one-time sort of password that you can then use, if needed, to request another token, but we'll get back to that. So first of all, you as a web application, this is the second time that the application comes into play. First time is just, hey, I don't know you. Go ahead and authenticate, and I'll wait for the token to come back. So then the token is posted, and you need to verify the signature. Inside of the token is a claim called what is the audience, the AUD claim, and that is specifically there to make you verify that the audience matches you as a web application, because you wouldn't want to just trust any token that is posted to you. You want to make sure that the user has authenticated and is posting a valid token for you being the web application. So verification of that signature as well. There's a cryptographic secret at the end of the token. You need to make sure that it's signed by the correct certificate, meaning the certificate that is used or the key that is used by Azure Active Directory. And those keys change as well, so you have to make sure to pull the metadata or use the frameworks that do it automatically, because the metadata contains those signing keys so that you can verify that signature without hard coding it into your application. So in the past as well, lots of people were hard coding those keys, and that means that whenever Azure Active Directory changes their keys, and they do it on a regular cadence, you would have to go and update your config, which is kind of bad, because if you forgot, you would just break your entire authentication. So Azure Active Directory exposes the signing keys as metadata. It's a standardized format as well. You verify the token signature based on that, and you say, okay, this is good. I can trust this token, and I can see inside of the token, which is a JWT, a JSON Web Token, who this user is and all the claims that I need to know. So that's fine. You know who the user is, and if you have direct access to a database or whatever, you can use that unique identifier of the user or his email address or whatever you want to use as a primary key, and go do your business. The next step is if you want to call something else, oh yeah, well, obviously to avoid the same flow happening for every page request, you want to have some sort of session set up, so typically issue a cookie that this user is successfully signed in, because it would be kind of boring if the user had to do the same flow at every request. So fine, then the user starts interacting, and then you could also say, well, now I'm going to have to call another API on behalf of that user. So me as a web application, I'm not implementing any backend logic, or I need to do an additional call, in this case to the Graph API, but it really could be any backend API that you control or somebody else controls. But to authenticate you as the end user sitting behind the browser to the Graph API or to that backend API, again, typically you use a token. Now, you cannot use the same token that you got here. First and foremost, that is an ID token. It's just to convey information about the identity. Second of all, the token has that audience set to the audience of you as a web application. So if you just take that token, post it at the Graph API, then the Graph API is going to say, hey, wait a minute, this may be a valid token, but it's not intended for me, so I'm not going to do anything with it. I don't trust you. So what you need to do is take that authorization code that you received in the beginning, post it to that token endpoint here saying, I have a valid authorization code. Now, please, can you give me an access token for this user that I can use to call the Graph API? So sure enough, if the authorization code is valid, it's a one-time use code, and this is exchanged for that access token. And then you also get a refresh token, so you can keep refreshing the tokens to avoid users having to sign in every hour, for example. So that gives you a new token that you can then call the backend service with. In this case, the Graph API, if you want to do a lookup of who is this user's manager, or in what groups is he, or whatever you want to do as on behalf of the user. So that is a very typical sign-in flow using OpenID Connect, and using that OpenID Connect ID token to identify the user in the web application, but also then using that authentication code, authorization code, to exchange for an access token to call some downstream API later on. That's just to set the stage. So now I want to show you that end-to-end sample solution that is public, so it's on my GitHub account. It's actually the thing that I use all the time with customers to walk through a couple of typical scenarios. So I have a lot of them in here. So for example, you can see that typical scenario at the top there where we have OpenID Connect from a browser onto an MVC site, and then the MVC site does that authorization code flow that I talked about to call some backend API. In my case, I'm not calling any graph API. I'm calling a to-do list web API. Very, very original, I know. But I was original because I added another downstream API, the taxonomy web API, and I even looked up a fancy word for it in the dictionary. The taxonomy API is really nothing. It's just a bunch of categories, and you can add your own categories. So the business logic, if you can even call it that, is nothing. But it's there to illustrate the point that you have one API calling another one on behalf of the original user. So you can see that the user is here behind the browser, but he's going to go through a couple of systems, and still his identity is going to be preserved across all of these calls. So that's the point, right? So there's multiple flows, multiple specs that are documented, that are public, that are open. Multiple people are implementing those specs. So Azure Active Directory is just one instance of a security token service that implements these flows. As I mentioned, Active Directory Federation Service is another. There's plenty. Identity Server is a really good open source implementation. So lots of things implement those same flows. So even if you leave today and say like, wow, interesting flows, but that Azure Active Directory thing, it's not for me, fine, at least you have a good understanding of what the different protocols are and how you can build those into your applications. So that's kind of the purpose of this, sample solution. So this is one scenario, and then I have others, a single page application, which has kind of a different flow to it, an implicit grant flow, and then multiple client applications, for example, that desktop app using code grant, or things like a daemon client using a client certificate. So there's no end user representing somebody physical. It's just an application like a batch service that needs to do a call. So they can do that using a certificate, for example. Also very typical scenario for IoT devices. So those are all kind of flows that walk you through this, these protocols. So you can just clone the repo. It is Visual Studio. You can open it in Visual Studio, and you should be able to just launch it. The structure of the source code is hopefully set up in a simple enough way that it's easy to get started. So we have the backend web APIs. We have a bunch of clients that are calling into those APIs, and a very small amount of common code just to print out or just do some common things. And so just to get back to that promise of just a few lines of code that you need to add, and this is even already a bit of a more, this could be less, to be honest. If you just want to do an OpenID Connect sign-in, then you can probably get away with 4 lines of code, depending on how you want to format it. But here I'm adding a few other parameters. But the basic point is this is an ASP.NET web application. I add a couple of lines, use OpenID Connect Authentication, which is standard middleware that ASP.NET MVC ships with. So this is built in. And that will trigger unauthenticated users to be redirected to an authority. So the authority is where the user needs to go. In this case, it's going to be Azure Active Directory. And the other important thing is that is coming later, is in the backend API, is the audience. The other thing I'm doing here is just for aesthetic purposes, is making sure that whenever the token comes in, and if you want to display the username, then this sets up the right claim type to show as the username. Otherwise, it's going to use a standard claim type that Azure Active Directory doesn't use. So this just makes it easier to pretty print hello, your name in this in the website. But so again, these lines of codes, and I found this in the solution. So if you want to do if you want to look into the solution yourself, I just did a global find on scenario between brackets, and this is where all of the different OpenID Connect and OAuth scenarios are highlighted in the code. So you can find it based on that. So these four lines of code would do the OpenID Connect part, but then as you saw in the flow before, you also get this authorization code that you can then exchange for an access token. So this is handled a bit later if you need it. So this is another scenario. This is the OAuth 2 authorization code grant for confidential client applications. That's a big mouthful. So here we have a simple callback that says, hey, some user authenticated and they gave me this authorization code. What do you want me to do with it? And here we're actually using ADAL, Active Directory Authentication Library, which is also a NuGet package that you can just use. And we are exchanging that authorization code for an access token and storing it in a cache for later use. So this is, again, a few lines of code to make sure that I got the authorization code, which is that one-time use thing to exchange for a token. This is going to give me an access token back that I can then later on use to call my backend API. So what does that look like? If I'm going to then call my to-do list API from within my web application on behalf of the end user, so I am on the server side, I'm running in IIS or app service or whatever. If you're running on Java, JBoss, or any backend service, you have that access token because you exchange it through the authorization code. Then you want to go call that other API. Typically, it's all HTTP using the bearer authentication mechanism, so OAuth bearer tokens. So what you typically do is make sure that you have an access token. If you already have that, then it's fine. You just create a new HTTP client and you set the authorization header to a bearer header with the access token. So in the end, what happens is you do an HTTP call to the backend service, and inside of those headers, this is the standard for OAuth 2 bearer authentications. You put in the bearer header with the access token, and then again at the other side, if we jump over to the to-do list web API, this is the other side. So we have the web application, it's got the token, it's going to post it to the backend API in a bearer token header, and then it is up to the receiving party, in this case my to-do list API, to validate the incoming bearer token and put again the user information typically on the current request. So here again, very small amount of lines of code, app.use Windows Azure Active Directory bearer authentication, and this will ensure that any post that comes in that doesn't have a valid token is rejected. If there is a token in it, it is validated. If it is valid, then it takes all the claims out of the token and creates a principal object in the .NET world. Again, for other platforms, you have similar mechanisms. So the token validation parameters, this is where the important stuff comes in with the audience. So this is where you need to ensure, for your sake, if you don't do it, then nothing breaks, but you're liable. You need to ensure that you configure I am this audience, so this is just a string that is pre-configured in Azure Active Directory. So this is me, and I only want to receive tokens that are explicitly intended for me to consume. So that's like the case where you send an ID token to the Graph API. Inside of the Graph API, there's also going to be some kind of check like that. So if the audience doesn't match, then I reject the token and the post doesn't come through. If everything matches, then fine. Your business logic gets called, in this case, for example, the to-do list controller, and except for those 2 lines of code before and this authorize attribute, that's all that you have to add. So literally 4 lines of code if you want. So very similar things happen with the other flows. I just want to jump into the way that you register those applications inside of Azure. This is the Azure portal where you can do it interactively. So if you want to register a new application, every application that you want Azure Active Directory to hand out a token for needs to be known by Azure Active Directory. So you can't ask for a token for any application whatsoever and just ask them, oh, just make sure the user is signed in and give me some information. No, you have to register the application, because otherwise Azure Active Directory will say, nope, application unknown, some fancy error, and then you can't do much. So all of my applications in the sample solution are registered here. If you want to do that yourself, it's, as I mentioned on the slide, there's not too much effort to go on. You have a name for it. So to-do list fancy client, because I'm going to make a really nice one. HTTP fancy client cloud, sure, .com. This is actually not that important. Unless you're creating stuff like multi-tenant SaaS solutions where you're publishing your application to the gallery and users will go in here to log on. But if it's just you managing the application, then this isn't terribly important. And then you get to choose between a web application or a web API and a native application. There's a difference between those two. One can store secrets or can be trusted to store secrets. A native application is something that is running on an end user device, and we don't trust end user devices. So they can get lost, stolen, hacked, whatever. So that's the only difference. They are not allowed to have any secrets on them. So you create the application definition based on the name, and then to-do list fancy client. And then you have a couple of properties that you have to set for a web application. A homepage logout. Oh yeah, this is just the web application, obviously. The reply URLs is the most important one. So whenever you say, my user isn't authenticated, please go ahead and authenticate. And at the end of the authentication dance, Azure Active Directory will post the token and or the authorization code back to your application. Now, where that is something that you pass in as part of the OpenID Connect request. But Azure Active Directory also checks that this is valid, because otherwise random hacker site could also be saying, yeah, give me a security token for that user and just redirect me to my malware site or whatever. So Azure Active Directory is going to say the site that you request, is that actually allowed? Is that pre-configured? And this is the list of allowed redirect URLs that you need to configure here. So your URL where your application lives needs to be in here. So that's it. Optionally, if you want to have access to other systems, other APIs, you can also say, I want to have additional permissions. So let me just open up my web application instead of going through the new one. So I have my web app client, and this has a required permissions set to Azure Active Directory first and foremost to make it possible to sign in, but also it has access to that to-do list API. So I explicitly have to configure which other systems I have access to from my own application. If this is not configured, then it will not issue a token. So you see there are a couple of checks in place to ensure security across the board, because if not, then it's too easy for random sites, or there's too much attack space to go for. So you have to explicitly define your applications and also explicitly define what access one application can have to another one on behalf of that original user, just to make sure that people aren't passing around user information just like that. So once these things are set up, then it starts working. So that is really, as I mentioned in the slides, there's not that many steps to go through. If you want to go through this yourself, by the way, inside of, let me show it in the GitHub site. Inside of the setup folder, there's also a script. So there's, if you're a bit like, oh, there's a lot of applications, do I need to go and register manually? No, there's a PowerShell script that does it for you in your Azure Active Directory tenant or in your ADFS server if you want to go for ADFS. So don't worry about setting it up. It should be fairly easy to start. Use the PowerShell script, and it will generate all of those application definitions and also allow you to put the IDs and the unique secrets and stuff like that back into the application configuration files inside of solutions. So you don't have to do any manual work. You should be able just to go through the PowerShell script and then run the application. So once that is up and running, you have your application. So this is the sample app for ASP.NET MVC. I also have one for a single page application running on Angular, another one ASP.NET Core. But this is a very simple site that uses that to-do list. And as soon as I hit anything that has that authenticate attribute on top of it, that's where the middleware will kick in. It's not any manual code. It's just saying, hey, you need to be authenticated for this, so I will redirect you. So if I click, for example, account or the sign in button or whatever, it will redirect onto Azure Active Directory. And here I can go through multi-factor authentication or whatever kind of flows and detection and stuff I would like to go through. So I enter my credentials, and then it's going to redirect back to my original application. So that needs to be one that is registered in Azure Active Directory. And then I get back onto my application, and it knows who I am based on that ID token that it has received. So inside of the ID token is my username, which is admin in this case. And just to show you what else is in the token, on the account page for those samples, I'm showing everything, just a dump of all the things that are in the token. So here's that audience. That's the GUID of the registration of the application inside of Azure Active Directory. Who has issued the token, at what time. So you can see in the pop-up that it was issued, well, pop-up disappears, a few seconds ago, that it's valid for an hour. And then what I also do here is call backend APIs. So from the web application, I will call the to-do list API, not to get the to-do items, that's on another page, but to get the information that the to-do list API sees from that user. So I'm going to have the token, the ID token, that is shown at the top. So this is coming from the ID token here, showing all the information that I have. I'm also doing a call to the to-do list API with an access token, the one that I got from the authorization code flow, if you saw before. And then asking the to-do list API just to send me back all of the information that you can see in that token. So this is coming from an access token. And this is all the information that the backend sees for that user. And then remember that I had this fancy taxonomy API as well. So I have the to-do list API call into the taxonomy API and again asking it, hey, what do you see of this user? So just to prove that the end-to-end flow is transferring all of the user information from the end user sitting in front of the browser all the way up to the backend taxonomy web API, including details like how did this person authenticate. In this case, I'm using a password. Could be phone sign-in or whatever other channel. So you can base trust decisions on the tokens that are coming into the applications. Yeah, and then the to-do list page itself is the business application, let's say, so I can add some to-do lists or create to-do items, and you would see those items come up in all of the other applications as well. So this is for web applications, and just to wrap it up, also showing, for example, a UWP app, so a Windows 10 application. I can start that as well. And then very similar, as I mentioned, this is a desktop application, but you should see, if I try to sign in here, this is going to open a pop-up window that is basically a browser. So in this browser, again, I'm going to enter my credentials. Anything could happen here, like multi-factor, like scanning, like needing to enter a certificate, whatever. Your application doesn't care. It just does a single call of authentication. And at the end of the flow, again, the user identity, if I can type, is then transferred into the calling application with the tokens that are coming in. So I'm seeing the same kind of claims and tokens in all of the different applications. Yes? There is a reply URL that's basically a dummy URL that you set up inside of the, so the question is, how does this work without URL? Because this is a desktop application. It doesn't live on a redirect URL, but you still enter, for UWP, it's a special URL that is reserved by Windows, but for a desktop WPF or something, you can just make up whatever you want and configure it on the Azure Active Directory side so that it knows how to trust it and post it back. And then the pop-up just detects here trying to redirect to some dummy URL. That's my sign to say the flow is finished, and I can grab the token from it. Yeah. Exactly. So that's a very good point you bring up. So the remark here is that this pop-up is basically reinforcing to the user that it's not my application that's stealing their password. I wouldn't trust a phone and enter my password into the phone app because I don't trust those developers. They could be storing it in their own database. The Windows 10 system, the pop-up that you saw is owned by Windows 10. It is a feature built into Windows to ensure the consistent browser pop-up experience. The authentication experience is always the same, so that hopefully smart users learn to trust that system and know that it's safe to enter their credentials in there and not inside of the end user application because they have no clue what the application is going to do with that password, basically. Yeah, very good call. And then just a quick note, because this is all about Azure Active Directory as a way to expose your organization's users to your applications. There's also other flavors of Azure Active Directory, which is B2B and B2C. Very interesting stuff as well. B2B is more for the partner-to-partner or business-to-business scenario, where you want to have your web application not only use your internal organization's users, but also want to enable other people to onboard onto those applications. For example, you're working with a partner or a vendor, and you want to give access to your application from that partner account. You can just invite those users. If they don't have an Azure Active Directory tenant yet, fine, we'll set one up behind the scenes, all transparent. They will go through Azure Active Directory. If they already have a tenant set up, fine, they'll go through their own organization. And the key point there is the users is still managed by their own organization. It's not up to you to make sure that this person has left that vendor's company. I need to revoke access. No, it's all managed by the vendor themselves, for example. So that's B2B, pretty important. But same flows, same code. So nothing special from that perspective. And then B2C is a really interesting other spin on the directory capability because that's business to consumer. That's where you don't want to target known users, but want to open your application to the general public. So it is for e-commerce, it's perfect for like large digital sites that you don't want to have a well-known list of users, but you just want to open it for any user. So you want to sell stuff, or it's the best reference case we have actually is Madrid. Who are using it. The soccer team has their millions of fans registered on the site. They're all going through Azure Active Directory B2C. So this is where users can sign up themselves, can do a password reset flow, can manage their profile, all without you having to write a single line of code. So this is outsourcing, again, the identity story, but not for your corporate identities, but for any general public identities. So that's just to wrap up the whole story around Azure Active Directory. Yep. You cannot transparently say, I'll take whatever you have. You have to, inside of your application, you have to configure which services you trust. So you can add code to trust multiple services. That would be a little bit more complicated. But you could say, I want to trust anybody that's in my company. Plus, I want to trust anybody that's authenticated using my B2C instance, for example. That's not going to be transparent. There's no single endpoint in Azure that exposes that, and that inside of your application, you're just going to say, trust that single thing. No, you have to build logic to trust both of them. Yeah. Yes. Yeah. But depending, so indeed, so the remark there is if it would be nice to have a single point because otherwise you're building logic into your application. The alternative, well, it depends on what kind of application framework you're using. For example, I think in ASP.NET MVC, it should be fairly simple to say on this area or on these controllers, this is my backend admin page, for example. In here, I want to have an OpenID Connect session with my Azure Active Directory instance that is tied to my Active Directory on-prem. And then for the general public, shopping, store, whatever, I want to trust the B2C directory. So it could be, it's not impossible at all, but it's going to be a little bit more complicated than 4 lines, maybe 8 or 12. But still, it's not going to be the end of the world.
How bad is it to use the password one time and do the call from your web server to Azure AD?
The question is, how bad is it to, and I love the way that you phrase it, how bad is it to use the password credentials flow? That is a flow where you explicitly ask the user for their username and password. and that is exactly what OAuth and OpenID Connect is trying to avoid. There are a few cases where you could get away with it, but in general, by all intents and purposes, the guidance is to stay away from the password credential flow, because that is exactly why these flows, the other flows, are implemented. If you have that scenario where you know you're distributing your phone app to your users in the company and they'll trust you because they have to, they work for you, and it's not going to be a general public thing, then maybe that's easier than setting up certificates on the device or whatever. So there could be a few exceptions, but in general, I wouldn't recommend the password credentials flow as unless as an escape hatch where there's really no alternative.
Quick question. So do you know when version 2 API will come to B2B tenants?
When? Sorry?
The version 2 APIs, they're not available on B2B tenants. Do you know maybe when will they
No.
implemented? Because they are on the common tenant and B2C, but not on B2B.
I don't know. So the question was, when is the V2 APIs coming to the B2B? I don't know yet. So send me mail and we can follow up offline. But I realize that we're far over time, so thanks for sticking around. Hope this was useful. So thanks.